Hey YouTube, thanks for visiting my channel. So this is the third session of West Bengal SET 2023 solution series of our paper mathematics. Okay, so in the previous two lectures we already discussed some papers, that is we already discussed in paper or in session 1 we discussed what we discussed ODE, I think PDE and integral equation, numerical analysis, and what I think one more topic they are okay. And this is the first lecture, and in the first lecture I think we will cover 12 questions. Okay, in the second lecture we will cover the classical mechanics, fluid mechanics, and what Fourier transform and calculus of variation. I think these four topics we discussed in the second lecture. Okay, and in the third lecture we will discuss, in this lecture we will discuss the linear algebra and complex analysis. Okay, so these two important topics, these two topics are very important for any higher mathematics exam, you all know that, and weightage of these two exams or weightage of these two topics are very big, you can say, in the every exam. Okay, so just a second, I will check once anyone. So anyone please comment me that the voice and audio and video are okay. Please comment me just once. I think some of you are watching me, and sorry for being late for some minutes. Okay, so please एक बार बोल दो कि ऑडियो एंड वीडियो ठीक है क्या, ऑडियो सही से आ रहा है ना, प्लीज एक बार कमेंट करके बता दो, प्लीज एक बार कमेंट करके बता दो कि ऑडियो एंड वीडियो ठीक से आ रहा है कि नहीं. ओके एमएस, ओके ओके ओके, थैंक यू फॉर दैट. ओके 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 ओके, थैंक यू डिजिटल टीवी. सो चलो करते स्टार्ट टू सॉल्व द linear algebra and the complex analysis. Okay, I think in this paper also 5 questions of linear algebra and 6 questions of complex analysis comes, and 5 or 6 or 5 or 6. Okay, so these are the questions, and total 11 questions in the session we will discuss. Okay, so those who are not watching me previously, so please like, comment, share and subscribe, and those who are watching the live session, please like the comment or sorry, like the session. Okay, so okay chalo ठीक. So the first question, this is question number 3, and this is X series question paper. Okay, all the questions number are from X series. Okay, so the questions is from what the linear algebra. Okay, the question is from linear algebra. Okay, so the question 3 says that let A be a matrix with complex entries if A is the Hermitian as well as the unitary matrix and alpha is an eigenvalue of A, then which of the following statement is correct here. Okay, so first it is given that A is Hermitian matrix. Okay, Hermitian matrix means what? We just replace the word symmetric matrix, and Hermitian matrix are same basically, because symmetric matrix we say a matrix symmetric which is in real field, and if the field is complex, if the element of the matrix are from complex field, then we say that this is a Hermitian matrix. Okay, so we just say, so A equal to A theta we write here, or A dagger you can say also, right? You can also write. Okay, so Hermitian means A equal to A dagger, and unitary means what? Or A theta. Okay, and unitary, this means what? Unitary means A theta, this is equal to I. Okay, so these two relations are given in the questions. Okay, now we put A theta equal to A simply, so A into A, this is equal to I, that means A square equal to I. That means what is the characteristic equation of this matrix? So that means the characteristic equation is x square equal to 1, or from Cayley-Hamilton theorem you also can say that every square matrix satisfies its own characteristic equation. From this theorem you can also say that, that means what is the value? X equal to simply plus minus 1 is the characteristic number or eigenvalue. Okay, so here it is given that if alpha is an eigenvalue of A, then what is the value of alpha? So clearly the value of alpha should be 1 and 1 or minus 1. So option B here clearly correct. Okay, now going to the next question. The next question, question number 4, and just a second. Question number 4, it says that let A is equal to 0 1 alpha, alpha 1 0 and alpha 1 alpha 1, then S is the basis for R3 over R if and only if. We all know that if these three vectors are or these three vectors forms a basis, then they must be linearly independent. Okay, therefore we just here say whether this determinant of this matrix, or if they form the basis, then the determinant of the matrix formed by these three vectors must be non-zero. Okay, so we just write the determinant, that is 0 1 alpha, alpha 1 0 and 1 alpha 1. This determinant should not 0. Okay, because if they form basis, then they must be linearly independent. Okay, so this implies if we just break this determinant, then we get 1 into what, 1 into alpha and minus 1 into alpha, sorry, minus 1 into alpha plus alpha into alpha square minus of 1, this not 0. Okay, this means what, alpha square minus alpha minus 2 alpha, this is non-zero. That means if we take common alpha and alpha minus 2, sorry, this is alpha cube, this is alpha cube. Okay, so this is alpha cube. If you take, if you common alpha, then alpha square, this not equal to 0, that means alpha not equal to 0, and alpha square minus 2 is not equal to 0, that means alpha square is not equal to 2 here. Okay, so this forms a basis if and only the alpha non-zero and alpha square is not equal to 2. Okay, okay, MS. Now going to the next question. Okay, the next question is the next question says that let x equal to x1 x2 x3, y equal to y1 y2 y3 belongs to R3 be linearly independent, and it is given a relation including delta. That means what, any vector of V which forms with the elements x and y, that is any vector of V is a linear combination of these two vectors x and y. Okay, then which occurs, then what situations occur, then we must have these three vectors, that is one vector from V. Suppose if we take any vector, suppose v1 or v from this capital V, then this v vector, x vector and y vector must be linearly dependent, because this v vector is a linear combination of these two vectors. Therefore we simply write what, suppose v equal to ubw here given, therefore we choose v small v or v1 equal to uvw. This is a vector from this capital V. Okay, vector space you can say. So that means uvw and x1 x2 x3 and y1 y2 y3, this determinant equal to 0. See, these two vectors are linearly independent, but this vector is a linear span of these two vectors. That means this vector is a linear combination of these two vectors, therefore we can write this determinant equal to 0. Okay, so this implies what, simply we can write u into what, u into x2 y3 minus x3 y2, okay, minus v into what, v into x1 y3 minus y1 x3 plus w into x1 y2 minus x2 y1, this is equal to 0. Now it is given the value of x2 y3 minus x3 y2, this is delta 1. Okay, so u into delta 1 minus, this is the value of delta 2, so v into delta 2 plus w into delta 3, this is equal to 0. I think just a minute, x1 y3 minus y1 x3, yeah, and delta 3 means x1 y2 minus x2 y1, yeah, so this is 0. That means which option is correct? So delta 1 u or u delta 1 minus v delta 2 plus delta sorry, this is delta u v w, yeah, this is w delta 3, this is equal to 0. I think here option A should be correct. Okay, now going to the next question. The next question, question number 16, says that what, let T be a linear transformation on R3 given by t x y z equal to this one, then find the linear transformation of this inverse transformation of, that is the T inverse xyz. So let us take, suppose T inverse xyz, this is equal to what? We take a, b, c, then what occurs? X, y, z, this is equal to T of a, b and c, and T of a, b, c is given here. So we just put the values. So this is 2a and 4a minus b and 3a plus 3b minus c. Okay, we just put the values of a, b, c in the place of x, y and z. Okay, so we get this one. Now that means what? X equal to we get 2a and y equal to we get 4a minus b and z equal to we get 3a plus 3b minus c. Now we need the values of a, b and c in terms of x, y and z. Okay, so this means from this equation we can get a equal to x by 2. Okay, so we get a equal to x by 2. That means C, either option A or option C can be correct. Option B and option D are incorrect one. So now from this relation we put y equal to 4a, means we put the values of a. So 4 into x by 2 minus 4 into x by 2 minus b. Okay, that means from here we get b equal to what? Simply 2x minus y. Okay, so b equal to 2x minus y. Which option? This option or this option? So here clearly option A is correct. There we, since we get the values of a and this is b, so this is the correct option. We don't need to proceed further, or we don't need to proceed further calculation. Okay, or you can check, then you may do the calculation. Okay, now going to the next question, question number 17, and this is again from linear algebra. Okay, this is again from linear algebra, and the question says that let A equal to Aij be an n by n matrix such that Aij equal to 3 for all Aij. That is, if we write the matrix, okay, all the elements are 3, 3, 3, 3 and 3. Okay, suppose this is an n by n matrix, then all the elements are 3, then we know that, so we can say this matrix is a scalar matrix. Okay, and we know that the scalar matrix is a rank 1 matrix. Okay, rank 1 matrix, but you can simply can do the row operations or column operation. You also get the rank of the matrix is 1. Okay, so rank of the matrix is 1, therefore we can write rank plus nullity equal to what? N, and the rank is what? Rank is 1 plus nullity. We have to find the nullity, LLIT by nullity, this is equal to n. Therefore nullity equal to, this is very easy question, n minus 1. Okay, dim Carty plus dim empty equal to dim, you can say these formulas also, or you can use the Sylvester's law. I think this law is called Sylvester's law. Okay, from okay, therefore here option A is correct. Okay, n minus 1. Now going to the next question, and these are the questions from linear algebra. Okay, now we start the questions of complex analysis. Okay, the first questions of complex analysis is question number 10. It says that if z equal to z bar square by z if z not equal to 0, and 0 if z equal to 0. Okay, then which of the following option is correct? Now it is given that f of z, this is equal to what? F z bar square by z. Okay, we know a sufficient condition that if it satisfies the complex form, we first define, or we first find the complex form of CR equation. What is that? Del f del z bar. If del f del z bar equal to 0, then we know that the function f is differentiable. Okay, so we first check whether del f del z bar equal to 0 or not. So del f del z bar equal to simply 2z bar by z. Okay, see here f is defined at z equal to 0, but this function 2z bar by z does not exist at z equal to 0, that is origin. Okay, so this is the function del f del z bar is not does not exist. That means what? The Cauchy-Riemann equations are not satisfied, and if the Cauchy-Riemann equations are not satisfied, then f must not be differentiable. Okay, therefore here simply option D is the correct option. Okay, now going to the next question. Okay, now question number 11 from complex analysis, and this is the questions from X series. Okay, so inverse point of z equal to 1 plus I with respect to mod z equal to 2. Here we have a formula. I just write the formula. We have the formula, simply formula based questions. Inverse image of any point A, that is A is a complex point, okay, with respect to, and it is given that mod z equal to 2, that is this is a circle. Okay, so we have two formula, inverse image of a point A with respect to circle and with respect to straight line. Here we use the formula for circle. Okay, with respect to the circle, what, mod of z minus c, suppose this is equal to r, mod of z minus c equal to r, that is this is a circle of radius r and center at c. Okay, so this is the case. Mod of z minus c equal to r is what, c plus r square by a bar minus c bar. Okay, so this is the formula to finding the inverse point of a complex point with respect to a circle. Okay, now here it is given that mod of z equal to 2, mod z equal to 2, that means r equal to what, and r is the radius of the circle here. Okay, so r equal to 2 here, and c is the center of the circle, which is equal to 0 here. Okay, therefore what is the value, and the point a equal to it is given that 1 plus iota. Okay, therefore the inverse image of the, or inverse point of this point z equal to 1 plus I is 0 plus what, r square means 4 by a bar means 1 minus iota and c bar means 0 here. So this is the value, that is 4 by 1 minus iota. Now 4 into 1 plus iota by 1 plus iota into 1 minus iota. Okay, so 4 into 1 plus iota by 1 minus I square, that is minus 1, that is 4 by 2 into 1 plus iota. Okay, so this is equal to what, 2 plus 2 iota, that is we write 2 and 2. Okay, so the answer is 2 and 2. Okay, option A is correct here. Any comment? Okay, MS, which question you say option B? Okay, now going to the next question. This is a very easy question. Which of the following functions is not harmonic? That is here the real part only given, that is uxy. So we have to check whether uxx plus uyy is equal to 0. If this satisfies, then we say that the function is harmonic, otherwise the function is, or the function is not harmonic. Okay, so if we check for the first term, then uxx plus uyy, this is equal to, see, sine hyperbolic x, derivative of sine hyperbolic x means cos hyperbolic x, and then again derivative with respect to x means, then again we get sine hyperbolic x cos y, and now uyy means sine hyperbolic x fixed, so cos y derivative means minus of sine y, and then again so with this minus sign, ux equal to what, ux equal to, we can write ux equal to minus sine y and sine hyperbolic x, and then uxx means this should be cos. Okay, so this should be cos uxx means, so we get again minus cos x and sine hyperbolic x, so this is equal to 0. That means this is the harmonic function. Again simply you can also check this one is also harmonic function, and this one is also harmonic function. So you can also check, simply these are very easy. So uxx plus uyy for the third option or C, this is equal to, we get 1 minus 1, which is equal to 0, and for option D, this does not satisfy the Cauchy-Riemann equation. Ux plus uy equal to 1 plus 1, this is equal to 2, which is not equal to 0. Okay, so option D is clearly correct here. Very easy question. Going to the next question, question number 24. The question is from complex analysis. It says that the bilinear transformation which maps the points z equal to 1, z equal to 0, z equal to minus 1 of the z plane into w equal to I, w equal to 0 and w equal to minus iota. Okay, so this is also a very easy question because the options or the correct options are given in the options. We just put the values of z in the place of z and check whether we get these values. So if we put z equal to 1 in this transformation, then we get w equal to iota. So let's check first for the first option. So if we put z equal to what? Z equal to 1 here, that means fz equal to what? Fz equal to if we put the values of z, then we get iota into 1. This is equal to iota, which is correct, it is given. And if we put fz equal to -1, that is iota into -1, which is sorry, z equal to 0. The second term is z equal to 0. So if we put z equal to 0 in the first transformation, then we again get w equal to again 0, and if we put z equal to -1 here, we get w equal to minus of iota. So here the first option clearly correct, and this is a very easy question. Okay, now going to the next question, we have to just check these points z equal to 1, z equal to 0 and z equal to -1 for the given transformation of fz which satisfies, or that is if we put this value for z equal to 1 we get w equal to iota, for z equal to 0 we get w equal to 0, and for z equal to -1 w equal to minus iota for which transformation. Okay, so this is very clearly or very easy question, and option A is the correct one. Okay, now going to the next question. The next question is a Lorentz series expansion. Okay, so the question says that, I think this is the next question, yeah. So it says that mod z equal to 1, so 1 plus 2z by, so it is given 1 plus 2z by z square plus z cube can be expressed in the form. Okay, so it is given that mod z is less than 1, therefore we have to expand like this function. This mod z is less than 1, we always expand this type of function 1 plus the quantity which is less than 1. Okay, and it is given mod z is less than 1. Okay, so now we write 1 plus 2z by, if we take z common, z square common, then we get 1 plus z. Therefore we expand this function. Okay, so 1 by z square plus 2 by z, this function remains constant, and 1 plus z का इनवर्स होगा. ठीक है, देखो mod z यहाँ पे लेस देन 1 बोला है, for that reason we expand this. Okay, if other interval given or any other reason or any other interval given, then there may be such another condition or another expansion may occur. Okay, so this is the case. So this is equal to 1 by z square plus 2 by z into, what is the expansion? 1 minus z plus z square, this is very known expansion, minus z cube plus z to the power 4 minus 1, this is the expansion. So if we multiply 1 by z square, then we get 1 by z square minus 1 by z plus first term multiply, we multiply first term and plus 1 and minus I think z and so on, and plus if we multiply this term 2 by z, so we get 2 by z minus 2 minus 2 plus what, simply 2z, I think, yeah, 2z, and then so on other terms may occur. So this is equal to, right, 1 by z square terms comes 1 by z square, and then plus minus 1 by z terms, plus here we get 2 by z terms, that means plus 1 by z terms comes, and plus 1 here, minus 2 here, that is minus 1 comes. Okay, so if we check the first 3 terms, then I think we should get the answer. Okay, so check whether 1 by z square plus 1 by z minus 1. Okay, so I think here option B is the correct answer. Yeah, so option B is the correct answer for this problem, question number 25. Okay, so I request those who are watching the live, so please like the session. Okay, and those who are new, so please subscribe the channel. So now we comes to the next question. This is again from complex analysis. Okay, the question says that if G is analytic at z equal to a and f has the pole of order k at z equal to a, then residue at z equal to a gz by f dash z gz into f dash z by f dash equal to what? So if we use here simply argument principle, then we all know that 1 by twice pi integration f dash z by fz, this is equal to dz, this is equal to what, number of zeros minus number of poles. Okay, and if there another analytic functions occurs inside the integration, that is 1 by twice pi I integration zz, where zz is an analytic function, into f dash z by fz into dz, then what is the, this is the modified argument principle. We simply write this is equal to what, summation number of pole, we can write m, we can write any other, you can use any other any other notation. Okay, n of ni into g of ni, this is the number of zeros, minus this one m of I think pi, these are the poles and corresponding g at p of I, that is these are the zeros, we put the zeros in the function g, and these are the number of zeros. Okay, and here no zero is present, therefore this term is not occurs in this residue, and these are the residue. So it is given that it has a single pole, that is f has a pole of order k. Okay, that means here simply occurs number of poles, what here, only k. Okay, so minus k into g, and what is the g is analytic at z equal to a. Okay, so g at a, I think this is the answer, minus k into ga, option C here. Now going to the next question. Oh, this is the last question. I think we solved all the questions. Okay, so these are the questions from what? These are the questions from complex and linear. So I think there are total 11 questions. Okay, so this ends today's session. So if you like the session, then please give a like to this video, share with your friends, and obviously who are new in my channel, so please subscribe the channel. Okay, thank you friends, see you again in the next video. Thank you.